So when it comes to defense evasion in something like an AWS environment or the cloud in general, there seems to always be options. So one of the first ones that maybe some folks in the audience might have caught out is, hey, if you're accessing the metadata service of the underlying node and you're trying to use those credentials remotely, I'm going to catch you because of guard duty.
That's super interesting because it's not even a matter only of container security, right? It's a matter of if you have a role assigned to an instance, you can maybe you want to only make that role available to this instance that runs in the cloud, in this place, right? So I think it's interesting that you have detective controls like that, but I think now at AWS, you have ways to restrict, to say this role that's attached to the instance can only be used from this instance. That's maybe something to look into as well.
You may have heard about container escape, but you probably would not have heard about escaping a Kubernetes cluster, specifically a managed Kubernetes cluster onto the cloud account. That's what we're going to talk about in this episode. We have Christophe and Nick from Datadog, who are security researchers, and they are going to share their research around how can you escape a managed Kubernetes cluster in AWS, Azure, GCP, and come out of the Kubernetes cluster and become potentially a cluster admin, or maybe even a cloud admin, or maybe even just access to the account itself. So this was a great conversation. We got to know about the different kinds of managed Kubernetes that exist, the different low-hanging fruits you may have. Also, some of the interesting questions around what are the benchmarks you can use and what resources you do look at if you are thinking about at least making sure the security posture of your managed Kubernetes is to the point that you want to. Because I bet you didn't know this, because I'm pretty sure little nuances that came out, like for example, your IAM role in AWS is not the same role that defines whether you are an admin on the cluster itself as well or not. So that was a big surprise for a lot of people who were listening to the conversation. Similar nuances do exist for Azure and GCP as well. We got to talk about a lot of that. We also spoke about how do you evade being detected as well. So Nick bringing his magic with that. How do you escape CloudTrail and not be detected if you're trying to do something, let's just say, a little bit gray in the AWS land? So all that and a lot more in this episode of Cloud Security Podcast. I hope you enjoy this episode. If you are someone who's listening to us for the second or third time, definitely give us a follow on our social media channels like YouTube and LinkedIn, where we live stream, and maybe on the audio platform like Apple and Spotify, where you have been kind enough to give us a lot of reviews and make us top 100 in the US, UK, Australia, and European countries. I do really appreciate your support. Thank you so much for supporting us. It really means a lot when we get to see so much support coming in from everyone. By the way, we're also at KubeCon North America in a couple of weeks in Chicago. So if you are hanging out over there, definitely come and say hello. We would love to talk to you and say hello in there as well. And maybe take some pictures as well if you're there. I would love to say hello to you at KubeCon North America. In the meanwhile, enjoy this episode on escaping managed Kubernetes clusters in a public cloud environment. And I will see you in the next episode. See ya. Peace. Hey, what's up, everyone? Briefly interrupting the program for sharing something that would save your inbox and your phone from vendor spam. Now, as a CISO, I would get hundreds of pitches from vendors in my inbox and over voicemail. I get why they do it, but the endless stream is exhausting for both sides. I recently learned about SageTab, who may have a better way of dealing with this complicated yet delicate relationship. Think of SageTab like blind dating for vendors and buyers. You get matched to meet with few relevant security vendors anonymously, meaning no spam or unwelcoming follow-ups. You only reveal your identity to the vendors if their pitch interests you. If you're tired of vendor spam, you may want to check out sagetab.io, your secret weapon for vendor discovery. Now back to the program. Welcome to another episode of Cloud Security Podcast. That's my dog in the background, but that was a different Ashish who was just there before. Clearly, you look a lot more clean over there. But I just wanted to welcome you to another episode. Today, we're talking about escaping clusters, specifically managed Kubernetes clusters. In case you don't know what they are, this is what we're going to talk about and how to escape them. So for this, I have two awesome people here. Hey, Christophe. Hey, Nick.
Hi,
welcome to the show.
Hey,
awesome to have you guys over here. And hopefully, I guess, at least open up the Pandora's box for what the hell is Kubernetes and managed Kubernetes and how do people avoid the common pitfalls in it. But before we go into it, I would love to hear a bit about yourself, Christophe, and then about Nick as well. Nick has obviously come on the show before. Christophe, did you want to give a bit of intro about yourself?
Yeah, sure. So I'm Christophe. I'm French. I've been living in Switzerland for the past 11 years now. And in the past, I've worked as a developer. I did some pen testing, and then I moved to a cloud security role. And now, since about 2 years, I'm working at Datadog, where I'm focusing on open source and cloud security mostly.
Awesome. By the way, there was no way I could have make out your French by listening to you. But I appreciate your intro and I appreciate you coming on the show as well. What about yourself, Nick? If you're going to get intro.
Yeah, hi. My name's Nick Frechette. My background's in penetration testing, and I'm currently a security researcher over at Datadog. I specialize in AWS offensive security, so trying to understand how an adversary can compromise or exploit AWS services, how they can be commonly misconfigured. And as a result of that research, sometimes I find vulnerabilities in the underlying AWS services and work with Amazon to make sure they get fixed.
Awesome. To start off with, because people sometimes may not even know what managed Kubernetes is and what are the other kinds of Kubernetes that exist, maybe Christophe, do you want to share what is a managed Kubernetes for people who have no idea?
Yeah, sure. So basically, and to make it short, when you set up Kubernetes yourself, you have to set up many things. You have to set up the control plane, the API server, the database that it uses, which is called etcd, and you have to manage that yourself. Which means that it's very hard to do. It takes a lot of engineering effort, and sometimes, maybe most of the time, it's not worth it. So back in 2015, Google Cloud introduced Google Kubernetes Engine. It went GA in 2015. And then Amazon introduced the Elastic Kubernetes service in 2018, as well as Azure with the Azure Kubernetes service in 2018 as well. So you can see that Google is a bit earlier from that front, probably because they were very involved into the development of Kubernetes. And so managed Kubernetes is basically, you don't have to manage that yourself. So you go to the Cloud Console, you create a cluster, you say, I want 5 nodes, and then you can directly use kubectl, basically, which means that the provider is going to take care of managing the control plane, etcd, and even most of the time, you don't have to customize the node, so you don't have to install yourself the node components such as kubeproxy or the kubelet. It's mostly a matter of abstractions. The control plane is managed by the provider. It's going to be scaled by the provider, monitored by the provider, and it's easier to get started with Kubernetes.
A great summary over there, man. What about pitfalls, though? Because I think one of the best ways people learn about how to secure something is probably by knowing what the gaps are and can they fix that as well.
So I think the interesting thing about managed Kubernetes as opposed to on-prem is that it comes with a lot of benefits. In particular, when it comes to managed Kubernetes, a lot of the technologies you're likely already familiar with, you can take with you. So if you need a load balancer for your Kubernetes cluster in EKS, hey, why
Yeah.
don't you use the Elastic Load Balancer that you're already familiar with? You need a place to store your containers. You could roll your own and use something like Harbor or something else, but no, why don't you just use ECR, which is Elastic Container Registry, AWS's own container store? So you benefit a lot from having all of those components already there that you're likely familiar with. But those exact same components have their own security concerns, right? How are you controlling who has the ability to push containers into ECR? How are you controlling access to your cluster and things like that? So the security of the cloud that you're already familiar with, you do still have to consider. And additionally, with managed Kubernetes, there are little nuances that you don't typically see on-prem. So for instance, in EKS, whoever created that cluster secretly has administrator access to the cluster. It's not something you can see by describing it or really any API calls. It's just whoever did it now has this secret control, and you want to make sure that role or that user, whoever did so, is properly locked down and monitored so that they don't come back in and get abused by an adversary. So I'd say that managed Kubernetes is interesting from a security perspective because it's like grafting on a second cloud provider onto your existing one where you already have to worry about the security of it.
Yeah, I think the fact that you get less easily shot in the foot with managed Kubernetes is pretty right. Because typically when you have to set it up yourself, you have many components to install. So if we talk about the control plane, you are going to have the API server to configure and to install, etcd, and these are all things that you can misconfigure, that you can expose to the internet by mistake. Same for the things that you install on the worker nodes. You have things like the kubelet, which is a small binary with a REST API that's going to accept incoming requests to run containers. And well, if you're doing that yourself, there's a chance that you're going to mess it up and to expose it to internet without authentication. And attackers know that. And if you look at honeypots, if you look at attack reports, you will see a lot of attackers that are scanning internet for that, which means that people do it, right? So I think that's one thing that you get very nicely when you use managed Kubernetes is that the provider is going to set that up for you. So you're not going to screw up the basics. There are other ways that you can screw up, but these ones you should be covered.
Interesting. And would you say, because to what you said as well, Christophe, I think the pitfalls are fairly obvious in terms of like the abstraction makes it really interesting. Because what I was going to come up with was the three major cloud service providers, they all have their own flavor of managed Kubernetes. Is there like a stark difference? And would the pitfalls be same across the board? Are they vary, or is the offering quite different? But if, in terms of the differences between the managed Kubernetes that's offered by, say, EKS and Amazon or by AWS or Azure, Google Cloud, what's the difference that we're talking?
Yeah, I can try to take that one, even if it's a tricky one. So I think most of the time you have to look at it from the lens of users, so people who are accessing the cluster, accessing the control plane and running pods, things like that, versus workloads that are in your cluster and that may be compromised and used by an attacker to escalate or to pivot. So I think in both cases, so in the three cases, it's really a matter of what are you exposing to the internet? Are you exposing your cluster to the internet? What workloads do you have in your cluster? And the different pivot points that they might have. I would say that in many cases, the main issue is when you have workload that sits inside of a pod that can basically steal the credentials of the worker nodes that it runs on. And that's applicable to AWS, to Azure, and to GCP. They just have different kind of protections around it. But basically, if you are inside of a pod, there are many ways that you can get access to the credentials of the node and then pivot to the cloud with that.
Oh, and I think people will understand, because my thinking over here was at least getting the foundational pieces out before we go into the whole container escape and how do you escape out of a cluster as well. So maybe let's just start with the first one then. I think another thing that I wanted to talk about was also the service account token thing, because I imagine, and maybe Nick, because you're from a pen testing background, and I think Christophe, you've been a developer before, when people are looking at how do I take over a system, they usually talk about the fact that, hey, I need to get domain admin. That's what the conversation used to be in a on-premise context. Is service account like the same thing in Kubernetes? Because I imagine it was what you guys were saying earlier. There's a lot of stuff that is abstracted. When I say I have pawned a managed Kubernetes, what am I really saying? Have I taken over the service account, or what have I done at that point in time?
Likely the best equivalent would be cluster admin. So rather than domain admin for AD on-prem, in a Kubernetes cluster, you want to escalate to cluster administrator, which would theoretically give you access to everything in the cluster. What's interesting is in a managed Kubernetes context, to some extent, the identity or the authorization and privileges are decoupled from the traditional IEM structure. For example, you could be a cluster administrator and not be an IEM admin, what we would traditionally classify as game over or like the highest level. So to some extent, they can be separate.
And that's a good call out. The main difference between the providers is going to be how they give an identity to people that are accessing the cluster. So typically in AWS, you're going to use your AWS identity. And then you have a mapping in the Kubernetes configuration that's going to say this AWS role has these Kubernetes permissions. Whereas in GCP, so you have one way of doing that, but you can also directly define at the GCP level who has permissions inside of Kubernetes. So basically, the place you have to go to see who has access to what is going to be different based on these cloud providers. And sometimes you have to go look in different places.
Oh, okay. So it's not that my AWS IAM role is not the same as cluster admin in EKS.
Basically, as of today, if you look at the permissions of an IAM role, you don't know if this role has access to your cluster. You have to go inside the configuration of your cluster, to be more specific, inside the Kubernetes config map, to see has this role been explicitly mapped to some permissions in Kubernetes.
What? Okay, so that would be very confusing for a lot of people. Is that the same in Azure and GCP as well?
So in GCP, you have two ways of doing that. You can either grant the permissions at the role level on the GCP side, or you can also grant it inside of the cluster. In Azure, I think you can also do both, but you can also grant it outside or inside. I will need to check, but I'm pretty sure you can do both.
So this is actually interesting because, as Asana was saying in the beginning, I think the best way people learn how to protect something is understanding what the gaps are. This is obviously a gap starting out straight away in my face, which is like, oh, if I'm using AWS, you can definitely look at this from a perspective of, hey, I have an obvious gap where my role management of identity that I do across the board in AWS is not the same as Kubernetes. It's where people get scared with the whole, hey, this is a data center within a data center that people say what Kubernetes is. That is still true in the managed Kubernetes part then. Would that be right?
Yeah, I guess that's true. And also you have to account for the fact that when you use two different cloud providers, you have to keep in mind how each works and you have to keep up with the changes too. And also I think the fact that you have multiple ways of doing it. So we were just saying that in Azure, you can grant the permissions to a cluster from inside the cluster. So from a config map or from a cluster role mapping.
Yep.
Or from outside, so from the Azure AD configuration. But I think that's confusing because if you just look one of these places, you're going to miss the other one. So I think having this complexity is quite bad for the practitioners.
Actually, I wonder people who are listening in, how many of you already knew about this? that there's the mapping between IAM role and specifically what the role of your cluster is actually is separate. So that's obviously already something that's glaring for me. In terms of another thing people keep talking about in that container space and Kubernetes space is something called container escape. And I almost sometimes get confused what people talk about when they say container escape. What's a container escape in the context of this managed Kubernetes world?
I think it depends, and we can probably argue like the specifics of what we mean by container escape. So, on its simplest level, to escape a container, there's a couple options. Probably the most common would be to abuse a kernel level vulnerability. So, one of the unique things about containers is that they all share the kernel of the host. If you can exploit that, you can pop out of the container and land on the host. And that would be like the traditional container escape. There have been vulnerabilities that have led to being able to abuse that. So I think most recently, the most popular certainly was Dirty Pipe, which I believe was early last year release, which was certainly a lot of fun at the time. But there are some other things that you can abuse. So things like Linux capabilities that are designed to divvy up permissions so that it's not running as like userland versus root. You can use capabilities, and certain capabilities can be used to escape out of a container and land on a host and take advantage of it. But you also have the opportunity of, I guess you would refer to it like indirect container escape. So perhaps if you land on a pod and you're able to pull a service account token, if that pod is privileged in the sense that it can run other pods or it can interact with the Kubernetes API server, that could be a way to escape in the sense that you can start maybe launching your own pods. You can access secrets, you can access other resources, so you can escape onto other hosts and perhaps do not niceties there. So there's a lot of options and there's a lot of potential ways. And of course, there's security best practices around each of those, trying to ensure that you don't overprivilege things, you limit access to the kernel and things like that.
And then when you're in the context of a managed Kubernetes environment, you have other things to consider. Because as Nick, you pointed out, you are in the cloud. So you have integrations, right? Your worker nodes, they need to be able to pull containers. They need to be able to do different things, talking to the cloud provider's API. And so the nodes, they have privileges, right? They can do various things, which is going to depend on the cloud provider. And the way that this works is that basically there is something called the instance metadata service. And this is true for these three clouds, which is a magical service that listens on a link local address. It's like 169.254.169.254. But anything that runs on the node can talk to, including the pods in a lot of cases. And so basically, if you are from inside a pod, in many cases, you're going to be able to call this metadata service with something like curl and pull the cloud credentials for the node that you are working on, which means that you can basically, from a workload that runs inside of the pod, authenticate as the node to the cloud environment, sometimes to the cluster, and you have pretty much a lot of bad things that you can do from there.
Yeah, and this probably sounds familiar to what we've always been talking about from a cloud security perspective of trying to prevent access to the metadata service. If you get server-side request forgery, if you get XML external entity vulnerabilities in an application running on a pod, in the exact same way you could pivot from an EC2 instance to the metadata service, you can do that here in EKS2, depending on the configuration.
Yeah, that's a very good call out to specify the stage a little bit. So let's say that you are hosting a web application inside of a pod. This web application is vulnerable to server-side request forgery. So that's a kind of vulnerability where an attacker can have the application request anything on their behalf. So the attacker can just ask, hey, give me the response of the instance metadata service. And they get back AWS credentials, for instance, of the worker node where the pod runs. So you can see how this can very quickly go wrong.
Ooh, this is like the juicy part of the intro as well. What a question from Stephen George. How crucial is to enable IMDS v2 in the context of EKS environment?
So I would say that it's very important, but it's very important because it means if you have an application that's vulnerable to server-side request forgery, an attacker is going to have a very hard time stealing the worker node credentials. That said, if your application is vulnerable to something else, like a remote code execution, a command injection, you are not protected because even if you have IMDS v2, if someone can run commands inside of the pod, they can just use IMDS v2, right? So the root cause of the problem, like what you really need to solve is something that runs inside the pod should not be able to get the worker node's credentials. And so the way that you are ideally supposed to solve that is by blocking the pod access to the instance metadata service. So it's not only IMDS v2, even if you should absolutely do that. So it's going to be deploying a network policy to block access to the IMDS from the pods. And on AWS and GCP, you have other options too. So on AWS, it's going to be setting the IMDS hop count to 1. It's an option that you can set when you start an EC2 instance. And on GCP is going to be enabling GCP workload identity, which is going to make sure that the pods, they can still talk to the metadata service, but they cannot steal their workload credentials.
Oh, okay. So I think that's a good point to call out, because you mentioned there is a difference. It's more important to know what's actually running inside the node. If that's vulnerable, IMDS v2 doesn't really make a difference. Would that be the same across the board for AKS and GKE as well?
So it's a bit different because, since recently in AWS, you have ways to enable IMDS v2 by default on specific AMIs. So for instance, Amazon Linux 2023 was released in March this year, and it enforces IMDS v2 by default. On Azure and GCP, by default, you have to add a specific header when you talk to IMDS. So it's not really vulnerable to SSRF. So I think that's the main difference, is that in AWS, you have to watch out for it. You have to enforce IMDS v2, or to make sure that the AMI you are using is enabling by default. On GKE and AKS, you should move to the other layer of protection, which is blocking the access to the IMDS.
Okay, so it's multifaceted.
Just a bit selfishly, since I'm very focused on like a cloud AWS specific thing, I think it's funny that we're having this conversation about the differences between the three major providers.
Yeah.
And since AWS was a little bit late to the party with having a header-based protection to the metadata service, even though it's been out since I believe 2019, they're still in some ways still playing catch up to the other providers, in the sense that we're still talking about instance version 1 versus v2, and it really shows the importance of like defaults and trying to build things secure by default. Hopefully they'll catch up in the near future, but for now we'll keep harping on this.
I'm sure they will catch up because they are adding new ways that to make it easier to enforce IMDS v2 by default. But there's also the fact that AWS has a lot of focus on stability, and sometimes enforcing IMDS v2 might break some things. You have some vendors that don't support it, things like that. But I think like having a way to provide practitioners to enable secure default is going to be super helpful. Just to give a number, last year we had a look at a bunch of environments in the context of a data study, and we saw that we had 93% of EC2 instances that were not enforcing IMDS v2. This was in October 2022. Things have improved since then, but this is just to show that, to Nick's point, if you don't enforce something by default, it's going to be very hard to have people to do it.
Which is actually a good segue into the next question that came in from Abhishek here, which was, what are the benchmark compliances that we need to fulfill to be more secured about Kubernetes architecture? Does it OPA, Rego works there? Any thoughts on OPA, or actually just the benchmark compliance in that context?
I was going to say CIS, but it's a bit easy. So CIS has a benchmark specifically for managed Kubernetes, which is pretty good. Yeah. So if you have to secure Kubernetes in the cloud, use the managed version. Don't take the CIS for Kubernetes and try to apply it in the cloud, because you don't have access to many of the things that CIS for Kubernetes tells you to do. I think that's one important point. And you have some provider-specific guidance. So from AWS, you have something called the AKES Best Practices Guide. For AKS, you have some things as well. So I think trying to have that mix of what CIS tells you, even if you shouldn't apply it blindly, and what the provider specifically is going to tell you is very helpful.
I think that's a good way to summarize it. Being sure not to apply it blindly is also a good call out. Your users have to have certain needs, and they may conflict with some of the guidance. So you may have to come up with alternative ways to try and support that and make sure it's still secure.
Yeah. And I think to what both of you called out as well, not everything in CIS is technically applicable for everyone. You just have to make the right guess for what is applicable for yourself as well. Good call out there. I think there was a response to the question from Ozzy as well, where Ozzy called out OPA Rego functions as an admission control that helps with enabling and enforcing policies. So you need to know what policies you need to have in place, and whether OPA Rego fits your use case as well. So I don't know if you guys have any comments on it, but I think that's pretty straightforward in terms of what OPA can be used for. Abhishek mentioned the version of CIS as well. And Justin had a comment saying, depending on the version of Kubernetes, one can look at pod security admissions, which has a few policies set dependent on workload as well. And I think
one point is that you can use pod security admission, which is one way to block dangerous workloads. And OPA admission controller is one way also that you can do that, or something like Kyverno. That's applicable to cloud and non-cloud clusters. For cloud clusters, you might have opportunities to have cloud-specific rules too. Typically, if you are trying to protect the IMDS from the pod that run in the cluster, you need to make sure that the pods don't run under the host network. Otherwise, the network policies that you deploy don't apply. If we want to take like a very cloudy stance on that, I would say that you can use pod security admission or something like Kyverno admission control to make sure that you don't have privileged or host network pods that would bypass the restrictions that you specifically put in place for the cloud environment.
And by the way, this is applicable for managed Kubernetes. Is that right? That's what you're referring to, right? As in managed Kubernetes in like AKS or EKS. Oh, awesome. And I think Ozzy just called out that the same thing that you had called out earlier, that there is an EKS benchmark available as well. Which kind of begs the question. I think we're in that territory of also, what are some of the low-hanging fruits? Because I think we're also in that territory for, yes, there are capabilities to manage policies. What are some of the low-hanging fruits in the managed Kubernetes space so that you can escape the cluster to the actual account subscription?
Yeah. So I think we talked a little bit about ensuring, at the very least, having preventing access to the node's metadata service, so you can't steal credentials and impersonate the node. But there are other things as well. Following least privilege is something I think in every single cloud security thing ever, right? Following least privilege is what we keep harping on. And that applies to Kubernetes as well, right? You don't want to have every single pod have a service account token that has cluster admin or something like that, something or default access, right? To have that level of permission. Other things to be aware of is the types of workloads that you have in your cluster, what's internet facing, what's maybe internal only, and prioritizing and understanding like, hey, it probably doesn't make sense if we have an internet facing pod or a group of pods that have a high level of privilege or a higher risk, things like that. And also being mindful that we maintain best practices in terms of least privilege on the nodes themselves, right? So Christophe mentioned the EKS nodes need to have certain privileges in order to operate. They need to be able to access the container registry. They need to be able to create network interfaces. And so we want to make sure those are scoped as tightly as possible so that we don't run into the risk of, hey, in addition to pulling containers, you might be able to, if it's misconfigured, push containers as well. And that can lead to a whole lot of headaches. So being mindful of following least privilege will always be sort of a core thing in the cloud for sure.
To ask about low-hanging fruit, so I want to try and make, if you have one thing that you need to take away from today and you are running clusters in the cloud, I think it will be 4 things. So instance one, it's 4. Don't put hard-coded cloud credentials in your cluster because people are going to discover that and to pivot to the cloud. Make sure to enforce IMDSv2 if you're on AWS. 3, restrict the pod access to the metadata service. So on AWS, it means blocking it with a network policy. On Azure too, and on GCP, it means enabling workload identity on GKE. And finally, just be careful about whatever is in your cluster that has access to the cloud. For instance, through workload identity or through IAM roles for service accounts in AWS. Make sure to understand that something in your cluster can pivot to the cloud. So you have to understand how these things fit together.
All right. Because this also begs the question that people always harp on the whole shared responsibility model. Because in my mind, I imagine a lot of people, when they hear managed Kubernetes, it's also a gray area where people just think, oh, isn't AWS or Azure or Google Cloud taking care of security? So what is the part that they control? Sounds like we're controlling everything.
They do still manage the control plane, so they run all those components for you. So from that perspective, you don't have to worry about it. While you can update the version of Kubernetes you're using, it's not like you have to do each individual one or each individual component. So that's something that you do get from managed Kubernetes. Additionally, if you want to spin up a new node or you're taking on more and more workload, you're going to have to add a new host, which in the cloud is way easier than trying to rack and stack stuff in a data center somewhere. So there are a lot of benefits. The primary security impact from the customer side of the shared responsibility model are those configurations and trying to ensure that you're following least privilege, you're not giving everybody access to control the cluster or have high privileges, and then being mindful of what the attack surface is. What can an adversary do if they compromise a pod? How can they pivot? Can they access? And things like that.
You said the shared responsibility model, and there's something that I think Scott Piper said that I like, which is it's not really shared, it's split. You're not going to share the responsibility of managing the nodes with AWS. They do it or you do it, right? So I think trying to frame that this way helps. And I think it's, if you want to make it very simple, basically, AWS manages the control plane and you do everything else, including what runs on the nodes. So I think the trick can be that to think that AWS or GCP or Azure, they do manage everything on the nodes. And depending on what you do, it's not true. So if you use AWS EKS, the default version, you have to patch your nodes, right? You have to update the OS packages that run on the worker node, things like that. So you have other things like AWS EKS on Fargate. For GKE, you have GKE Autopilot, where the nodes are also going to be managed themselves. So you don't even see the worker nodes, which brings a lot of security benefits. You have also less flexibility. Maybe it's more expensive, I think being aware that you have, even in managed Kubernetes, you have different levels of abstractions is very helpful.
I think that's an interesting point. I forgot to mention that there are actually layers to that managed Kubernetes part as well, where some of that can be controlled by the cloud service provider. So do all three cloud service providers have capability for that, where similar to Fargate and the, I think it was Autopilot that you mentioned? So that exists in all three cloud service providers, where the split quote unquote responsibility, the split responsibility is a lot more taken away from us. I didn't realize there, because
Yeah.
so maybe just for the Fargate perspective, which is my understanding is it's a serverless version of that. You don't have to manage the infrastructure or the host. What other things go away when you go for a Fargate option for managed Kubernetes?
So I think you have a few security benefits. So all the operational things that you don't have to manage, right? Like I said, all the patching, things like that. I think, if I'm not mistaken, Fargate also blocks pod access to the IMDS or enforces IMDS v2. Like you have some security benefits. For GKE, when you use GKE Autopilot, you have also workload identity that's enabled by default. So again, your pods, they cannot get the workload credentials. And I think it's a matter of if you can focus on building stuff instead of having to patch your worker nodes. And if it makes sense for you, I think it's a great deal.
You don't seem comfortable with it. Take it if you feel like going for it. But would you say the reason I asked that question is because the low-hanging fruit that we just spoke about just before, I feel like that would still apply. Like to what you said earlier, if your node by itself is vulnerable by default, it doesn't matter if it's a Fargate or if it's a EKS. Would that be right?
It matters in the sense that it's much less likely than AWS takes more time to patch their nodes than you do, right? So if you use like AWS Fargate and you don't even see the worker nodes, you don't even have to patch them, you can assume that AWS is going to patch them to secure them at least as good as you would do it.
The one thing I wanted to mention, since you mentioned container escapes and whatnot, a couple of the benefits of Fargate is that in some ways they do restrict what you would otherwise expect on like a Linux server. For example, they do limit access to certain Linux capabilities. So that would mitigate a lot of the risk with privilege escalation or escaping a container. I believe Fargate also either disallows or blocks privileged containers as well. Again, mitigating the risk of container escapes or accessing things that would be problematic. So I think in those senses, something like Fargate does help mitigate some concerns you might have around container escapes in a Kubernetes environment.
In the context of just running containers as well, I think there's something to be said. Christophe really had some on there as well in terms of the 17 ways to run containers, as you called out.
Yeah, because we're talking about managed Kubernetes here, which is part of the problem, because there's someone that you might know called Corey Quinn. And he basically wrote a while ago something called 17 ways to run containers in AWS, which is fun by itself. But then a few months later, he wrote a second blog post, 17 more ways to run containers in AWS, which I think shows that you were talking about EKS, AKES, GKE. There are a lot of other services too that operate at different layers. So if you just want to take AWS, we have Lambda. You can run container images on Lambda. We have ECS, Elastic Container Service, that are all running containers, even if it's not in like traditional Kubernetes. And sometimes the same things apply, right? If you can talk to the IMDS in ECS, you can also steal credentials, things like that. So there's some complexity for people who need to use these services because sometimes they're not as well researched or there are not as many security guidelines. I just wanted to call out that there are many ways to run containers. EKS, GKE, AKS are very popular, but you have a lot of other options too.
Yeah, and a lot of those other options are certainly a lot simpler as well. Kubernetes has a lot of benefits, but one of those is definitely not being simple and easy.
Yeah, I definitely get that much. And I also feel that the whole notion of, I can see why people get nervous when they talk about Kubernetes as well, because it's almost like you took some time to learn cloud and now you have to add another layer on top of that as well. That definitely would make me a bit nervous as well. Okay, because maybe this also begs the question. I think if we go further deep into the whole managed Kubernetes part, I named the title to be a lot more around escaping the managed Kubernetes cluster. And I think you guys had some research on this as well. With that initial understanding of what escaping containers is, what is escaping a managed Kubernetes cluster? What does that mean?
So mostly when we say escaping in the context of managed Kubernetes, it can mean you escape from the container to the node, but it can also mean, and I think that's one of the most interesting vectors for an attacker, you escape from the pod to the cloud environment, right? So one way that we can do it, as we saw, is by accessing the instance metadata service. Then you are authenticated as the node against the cloud environment. So first, the impact of that. In AWS, by default, you don't have a lot of permissions as a node, but you can do things like describe instances. You can destroy network interfaces. In GCP, by default, you are using the default compute service account with a read-only scope, which basically means that you can read any bucket, GCS bucket, or big query dataset in the project. It can easily be used to pivot from a pod to authenticating to GCP and stealing stuff in GCS, for instance.
Oh, wow.
For Azure, it depends a little bit more on the setup because by default, it doesn't have permissions. But in all the clouds, you can do the stuff that the workers need to do. So pull the container images. And from there, you have some opportunities to relook at the source code, maybe find secrets in the container images. There was a very nice paper a few months ago from, I think, someone in a German university. They looked at a lot of container images, and they showed that many of them had credentials in them, including AWS access keys or stuff like that. And it can feel very dumb, but when you use things like multi-layered builds, I promise you, you can get hit by that.
Oh, really? So it's actually quite common. Like,
I won't say common, but I think the numbers they had, and we can link to the paper in the show notes, was 8.8% ish, something like that. So 8% of the containers that they looked at had some credentials in there. Not all of them were cloud credentials. Some of them were TLS keys or things like that, but there were also some cloud keys. So I think that covers the first attack vector.
In a EKS environment, if you get access to a pod, you get access to file system, if there may be a service account token sitting on the file system @var run secrets, that token's super interesting because there's the potential that you can exchange that for normal IEM credentials using a particular API call. And that could potentially help you go from sitting inside of a Kubernetes cluster, and now you're able to assume a role inside the AWS account itself. And then from there, you can do all types of fun stuff that we normally try and look for: privilege escalation, lateral movement, accessing resources, and so much more. So even if you are landing on a pod, you can still move into that cloud control plane, which is super interesting. Another thing to consider or think about would be something like a Kubernetes operator. So being mindful of like what you deploy into your cluster. Say you want to take advantage of something like the Kubernetes secret storage CSI driver or a project like external secrets. If you deploy something into your cluster, if a attacker is able to steal the credentials of the node, they might be able to coerce a certain pod to run on it. They could try and steal the service account token from that pod. And then they may be authenticating, in the example of like external secrets, potentially having access to every secrets running in something like Secrets Manager, things like that. So being mindful of the types of things that you're deploying into your environment may also give you an idea of the attack surface that could be abused.
I just want to go into a bit more depth into what you said about when you are authenticated as a worker node. So if you stole credentials from a worker node, what you can do, and in some cases, so for instance, on EKS, you can do it. When you are authenticated to AWS as a worker node, it means you are also authenticated to the cluster as a worker node. So which means that you can do in the cluster too things that the nodes can do, including one of the things that the nodes need to do is to create service account tokens for the pod that they run, right? If you are a node and you run a specific pod with a specific Kubernetes service account, you need to first ask the API server, hey, can you give me a service account token for this pod? And then you inject it into that pod. Now, as an attacker, the way you can abuse it is that you can basically use kubectl or the Kubernetes API to say, hey, give me a service account token for this pod. And then you are authenticated as a pod, which means that if you find a privileged pod on the cluster, you are able to go from authenticated as a node to authenticated as a privileged pod that could do things like create pods or look at fig maps or secrets or things like that. So I think that's interesting because it means you start from the cluster, you pivot to the cloud, and then you go back to the cluster, try and do other things. So it's you're like bouncing around between the cluster and the cloud.
So is this attack path actually logged somewhere? Because I'm also thinking from I guess people listening in, I imagine some of them are also going, is there a way to pick that up somewhere as well?
That's a really excellent question. So when it comes to defensivation in something like an AWS environment or the cloud in general, there seems to always be options. So probably one of the first ones that maybe some folks in the audience might have caught out is, hey, if you're accessing the metadata service of the underlying node and you're trying to use those credentials remotely, I'm going to catch you because of guard duty. For those perhaps not familiar, guard duty is a managed threat detection service offered by AWS. And due to some of the sort of well-known tactics and techniques that we use against AWS environments, AWS has built some detection rules for using stolen credentials remotely. These are the instance credential exfiltration findings. And if you steal a pair of access keys from an EC2 instance and try to use them from your home network, that's going to trigger an alert in the guard duty service that, hey, these credentials are stolen, they're being used off the host, and that's not good because that isn't good. Certainly, that's pretty suspicious. What's interesting is, obviously, as an attacker, we don't want to get caught. And there is a way around it. For whatever reason, VPC endpoints, which is a service offered by AWS to allow air-gapped networks the ability to still interact with the AWS API, by using a VPC endpoint and routing your API traffic through it using those stolen credentials, it doesn't trigger the guard duty alert. Yeah, presumably it's like missing some metadata or something else that they use, or perhaps they're only accounting for like the VPC traffic and the general internet traffic. They're not thinking about VPC endpoints. This is a method that we can use to bypass that detection and operate a lot more stealthily. Then there's always trail bypasses, which I'm very fond of. For those not aware, over time, what started with a singular, hey, you can bypass CloudTrail in this very specific way, and it was shocking at the time. Now it's here's a whole bunch of ways we found to bypass CloudTrail for a variety of services and more coming out soon. Wink, nudge, nudge. So when we talk about CloudTrail bypass, that can take either the form of permission enumeration. So typically adversaries don't have a way to know what level of permission they have. And so what they end up doing is they will brute force and be very noisy to figure out what they can access. There are certain ways that you can bypass CloudTrail and do that a lot stealthier. So that's one option. And then, of course, there are just pure bypasses where you can interact with a particular AWS service without logging to CloudTrail. And so that from the victim's perspective, they have no way of knowing that activity has occurred. So for a attacker who's trying to evade detection, these are some of the things that they would probably use or they'd be interested in. And there's definitely a lot of other opportunities as well.
Awesome. And I think someone just shared the link for your Hacking the Cloud website as well. I was going to say, is that how about other cloud? I don't know if you had some chance to research onto some of the other cloud providers as well in terms of, does it get picked up by them?
It's funny because I personally only do AWS. It's the only thing I'm focused on. But when I was at For CloudSec, I had the opportunity to meet an engineer at GCP who described to me that he's been working on the exact same thing internally, and it worked as well. So I know that there are other folks working on this research or applying the idea of trying to evade the logging setup of the cloud provider they're working on. So it's definitely applicable to other cloud providers for sure.
Oh.
That's super interesting because it's not even a matter only of container security, right? It's a matter of if you have a role assigned to an instance, you want to only make that role available to this instance that runs in the cloud in this place, right? So I think it's interesting that you have dedicative controls like that, but I think now at AWS, you have ways to restrict, to say this role that's attached to the instance can only be used from this instance. I think that's maybe something to look into as well.
Maybe taking that leap word further, because you had escalation privilege as in the EKS cluster that you had called out in one of your talks as well. Did you want to talk about that as well, man?
Yeah, sure. So I think one that's interesting is that we said it before, but the way that in AWS EKS you manage permissions is from inside the cluster. So you have a config map that's called AWS Auth in the kube system namespace that maps AWS roles to Kubernetes permissions, right? And so it's interesting because if you have the rights to edit config maps in the cluster, it means that you can actually map your own AWS role to being a cluster admin. And then you can escalate this way from whatever access you might have to cluster admin. So I think it's something to know and to be aware of, that if you are granting something or someone edit config map permissions, you might not be aware that you're actually granting cluster admin to the cluster as well.
So the config map is pretty interesting. Would I be able to change that if I was using Fargate versus EKS as well? Or is that just a like EKS only thing?
That's a great question. So you have EKS on Fargate. I think for EKS and Fargate, it should work the same. For other things, yeah, so for EKS on Fargate, it should work the same.
Okay, it should work the same. And so would this escalation privilege of config map would be applicable for Azure as well? Because you can manage that there as well. Would that be right?
So it will be different because the way that you manage these permissions in Azure, it's not through a config map. In Azure, the way you would grant that is through a cluster role binding. So if you are able to modify cluster role bindings anyway, you're going to be able to escalate your privileges. For GCP, it's the same. The way that you can grant access to a cloud in your cluster is also through a cluster role binding. So it's a bit different in that sense.
Okay, cool. No, thanks for sharing that as well. So Ozzy had a question around the fact that if an application requires an automated service account token besides creating a custom service account and preventing the use of default Kubernetes service accounts, what else can we do to reduce the Kubernetes attack surface?
Yep. So I think these are all great things to call out, especially preventing the use of the default Kubernetes service account token. The big thing, I'll say it again, following least privilege, ensuring that if the pod needs to access 3 things, make sure it can only access those 3 things. And being mindful that in the event that it does get compromised, that an adversary may have access to those things, and you want to ensure that they don't escalate privileges or access things that you're not expecting.
So Steven had a question, how, and this is a good one as well, how Managed Kubernetes Auditing Toolkit, MKAT, can help identifying common security issues in Managed Kubernetes environment. Maybe if you want to share what MKAT is, then you can talk about how people can use it.
Yeah, sure. So it's an open source tool that we released a few months ago. And basically, it's trying to help with a few pain points in Managed Kubernetes. So for now, it's only focused on AKES, but I'm hoping to add support for GKE too. And basically, one of the things that it does is you run it in your cloud environment, and it's going to look at your Kubernetes service accounts and your IAM roles. And it's going to show you this specific service account, this specific pod can actually assume this AWS role. And it's going to generate a visual map of that to be able to show very quickly what are the kind of cloud pivots that you have from your pods to your cloud. That's one of the things that it does.
Yep.
And it does also 2 other things to test if you properly blocked pod access to the IMDS. And it's also going to try and find AWS hard-coded secrets in your Kubernetes clusters. So it looks at config maps, secrets, and pod definitions. So yeah, that's the goal.
Awesome. And thank you for calling it out, Steven. Also, shout out to Steven for calling out Nick's blog as well, which is hacking the .cloud version as well. You can look out for the guard duty bypass. I'll make sure I'll have both the links in the show notes as well. I had a comment from Abhishek around the whole secret leak detection as well. I think it's called out the SemGrep rules. So what is Secret Manager? How you mentioned MKAT can look at secrets as well. So would that be just the secrets, like in terms of there's the AWS Secret Manager, there's Kubernetes secrets, which one are we referring to over here, at least in the context of MKAT?
So in the context of MKAT, it only looks at hard-coded AWS access keys, which you should typically not have in a Kubernetes cluster, even in AWS, because there are much better ways to get your pods access to the cloud environment. Namely, it's called IAM roles for service accounts, which allow you to easily do that in a secure way with no hard-coded and long-lived credentials. In general, about hard-coded credentials and how to find them, I think the easiest way to not leak static cloud credentials is to not have them. So I would try to put an emphasis in fixing the root cause. If you are leaking access keys, it means that you have access keys. So how do you get rid of that? AWS, it means not using IAM users, trying to use something like an IDP like Azure ID or Okta to redirect into the accounts, and then making sure that you block the creation of IAM users, because many people might think that you need them to run stuff on your laptop on AWS. And then you can move into the detective controls, like using something like Git leaks, Git Guardian, or something that you can run in your CI pipelines on your source code to find secrets.
When it comes to secrets detection, one thing I always want to stress, because I used to run into this a lot as a pen tester, is if you are a security engineer, or perhaps developers are listening, having a well-defined plan for rotating those secrets is super important, because you don't want a situation where the pen test team finds creds or they find secrets and they go to the team and report them, and the team goes, listen, if we were to rotate these right now, we'd have to take out all of prod for a day, and even then we don't know what'll happen. So building those game plans around resetting and revoking credentials is super important, so that when they do get leaked, because they will get leaked eventually, having that plan ready to go that you can execute in literal minutes will save you a lot of hassle down the road.
Awesome. And I think I've got a question from Rajesh as well. Thank you for sharing that, Nick, by the way. By default, if a cluster creation has admin privileges for a long time, that is too much threat. How do we avoid this? And since if we delete that role with system master, then will we lose access? How to prevent AWS AuthConfig map-based attack? And I guess there's a follow-up from Aussie just below that was around the more, I'm not sure you can delete the system master role. Best you can do is assume that the role, it's unavoidable to adequately monitor. But would you agree, Christophe, or do you add something to it?
Yeah, I think that's a great call out. And if some people join, the issue is that when you create an EKS cluster, by default, you have admin access to it, even if you don't see it anywhere. So it's hidden. So I think one of the recommendations that AWS has somewhere, or one option that you have at least, is to create a role, create the EKS cluster from that role, then configure your AWS config map so that you map specific roles, and then delete the role. That's one option. Maybe it's a bit extreme, but that's one way of doing that. Otherwise, you're trying to make sure that you are protecting this role. But as far as I'm aware, as of today, there is no way to remove that shadow admin. It's probable, or maybe AWS has plans for that though.
Would you say a user access review, like a period, it's probably manual way to do it. You know how people have been doing user access review for some time where, or maybe it gets a bit tricky because you do user access review for AWS, but that's not necessarily access review for Kubernetes. You're in that gray area for someone who's going to go deeper or not as well.
So in that case, it's not going to help because you cannot see who created the cluster. If you look at the AWS console, you don't see who created the cluster. So you would have to look at in CloudTrail logs who originally created that cluster, what role. And from there, you can see who still has access to it, does the role still exist, and try to figure out who is using that role, basically. But you have to look in the logs to be able to figure that out currently.
Oh, and Jay had a follow-up. Even if you wrote in the secret, should they be propagated to individual workload? Do you have any recommendation for propagation security?
I think the best way is to not treat secret rotation as something that you have to engineer, right? It should be short-lived credentials by default. When you have short-lived credentials, it means that there is a built-in mechanism to do that, right? If we take the example of IAM roles for service accounts, which is the way recommended to get your pods access to AWS stuff, the way it works is through the native Kubernetes service accounts. So you have the kubelet that's going to inject the Kubernetes service account in the pod and frequently refresh that. So I think overall, it's more a matter of trying to have that mindset of all the credentials are temporary. And by default, this is getting rotated by design, as opposed to having very hard to follow processes like you have to rotate this access key in this config map, and then you have to restart all your pods. You have to watch the files that are in the pod and to restart your application. So I think it's more a matter of mindset and trying to use mechanisms that support that by design.
That's always the optimal if it's built in and supported. For some things that may not be there. So for example, like GitHub or GitLab access tokens and other API keys similar to that. When it comes to propagation, something to keep in mind is assessing the situation. So as an example, say you can rotate a secret in a minute. That's great. You don't want to do that if there's still an adversary in your network or in your environment, because then you're just handing them the new keys. That's something I've experienced as a pen tester, of them not realizing like, no, I still have a shell on this box and I see that what you're doing. So that can be something to keep in mind, is making sure that you assess the situation, try and assess if the adversary still has access to your systems, if they're still around, and try and force them out first before you rotate and things like that. And of course, maybe you're in a situation where if you were to not rotate, you're going to lose money, or there's going to be some other impact to the business, because of course, at the end of the day, we're all trying to support the business, right? Bearing in mind that you have to operate around that, and perhaps you do have to rotate, and maybe you'll have to do it a second time, being mindful of what the situation is for sure.
And I guess to your point, that you can always use a secret manager, which is outside of the cloud context as well, to manage it. So I think because Rajesh asked about the secret rotation outside of the cluster, again, this is just general advice. Secret manager could be non-cloud specific as well. You can use HashiCorp Vault or other providers as well to manage and rotate secrets outside and without hard coding as well. We're towards the tail end of this as well. And I wanted to make sure at least I got most of the questions out. In terms of, I guess we spoke about some of the low-hanging fruits. We spoke about things that are obvious people should look out for. I think the biggest question people normally don't have an answer for is, where do I start learning about this? But I mean, they can obviously listen to your talk, Christophe and Nick, and you guys did a talk at Sense, I think it was early this week, and KubeCon as well. But is this information usually, like, I know, but Nick, you have a blog as well, Christophe, you have a blog. Where do people learn about this, man?
Yeah, honestly, I think the best thing to do is to get your hands dirty and try it out for yourself. If you're interested in doing managed Kubernetes, spin up a cluster in the cloud of your choosing, bearing in mind the potential costs, of course. If I recall correctly, the EKS control plane is not cheap to run. So being sure to tear it down when you're done. If you'd like to get a little sort of local experience, we've talked a lot about managed Kubernetes, but you can also run Kubernetes on your own home network. I know within the self-hosted community, things like K3S, which I believe is a Rancher product, is very popular. A single binary to spin up a cluster for you. There's also things like Minikube that you can run in like a VM on your local workstation. While Kubernetes can scale to massive enterprise levels, you can also totally run it at home on your laptop or on your desktop and get a lot of experience that way. So I think getting that hands-on will definitely help. And you can apply that knowledge to when you want to start building a crazy enterprise cluster in AWS or other cloud providers.
Yeah, or maybe get some cloud credit from people so they can just spin up an expensive one if they want to.
I think getting your hands dirty is very important. To be able to secure something, you need to actually use it in the way that it was intended to. So for managed Kubernetes, it means really creating your own cluster, trying to, how do you authenticate to that cluster? How do you have things in that cluster authenticate to the cloud? And trying to figure out how these things work together. For AKES specifically, I took some time to try and wrote a blog post that describes how these different things work. So we can share that in the show notes, but that's trying, that's really a matter of how do humans and things authenticate to the API server, how do workloads get access to the cloud environment, and what does the integration between the cluster and the cloud looks like.
Awesome. Thank you for sharing that. I'll make sure I'll have those links as well onto the show notes. So that's most of the technical question. I appreciate everyone joining in as well. So I've got 3 more questions which are non-technical for both of you. For people who are probably regular to the show, listening in, they probably know the answers. Oh, they know the questions already, not the answers. Answers is what you're going to give me. So first one being, what do you spend most time on when you're not working on researching cloud and technology? Maybe I'll start with Christophe first, because you're first time on the podcast. What do you spend most time on when you're not working on researching cloud and tech and all of that, man?
Yes, I love being outdoors, doing skiing, hiking, things like that. I also have a 1.5-year daughter, so
Nice.
that's also a big part of my free time.
She'll definitely take most of your time at the moment, I imagine. What about yourself, Nick? Thanks for sharing that, man.
Yeah, for me recently, when I'm not doing like cloud related stuff, just recently, and I don't, this will apply to the 0% of the audience who live in Bloomington, Illinois. Just recently, a cat cafe opened in town called the Cat's Meow. And it's a place you can go to get coffee and then hang out with 10 to 15 cats. And my girlfriend and I have been going like, I don't want to say every day, but pretty close just to hang out for a bit. It's been a lot of fun for sure.
Oh, wow. I've heard that in Japan. I've never heard that in US. So it's pretty awesome that you guys have that close by. Thanks for sharing that. Next question. What is something that you're proud of, but that is not on your social media account? And maybe Nick, you want to start first this time?
Ooh, okay. Something I'm proud of. See, the thing is I post everything on social media. I don't think this is on social media. I built a server rack. I'm very big on self-hosted, like running my own infrastructure at home, which is somewhat silly since I do cloud security all the time. Yeah, maybe that's because I do cloud security research. I choose to run everything at home. But I built a fairly elaborate server rack with UPS, a couple servers, and some networking that I'm pretty proud of. Running an entire cloud at home for sure.
Wow. What about you, Christophe?
That's a very hard one because same as Nick, everything that I'm proud of, I post it on my social media. So I don't have a good answer for you.
Okay, fair enough. Okay, final question. What's your favorite cuisine or restaurant that you can share with us? Christophe, you could probably start with.
So I did something that I really like is called shumai. It's a kind of traditional Chinese dumpling, which is very nice. So if you ever see that, it looks a bit round, a bit yellow. It has like shrimps in that. I loved eating it. I tried baking it twice. It didn't work very well, but maybe someday.
Yeah, making dumplings is super hard. I don't know how those Chinese aunties do it. Like in the restaurants that you go to, they're just basically making it up. I'm like, wow. By the way, if you haven't tried it, I would definitely recommend trying xiaolongbao as the dumpling type as well. I don't know if you tried that, because these are dumplings with a little bit of soup inside. So when you bite into them, there's a little hot soup that comes out. I'm so hungry right now after listening to this. But Nick, what about yourself, man? What's your favorite cuisine or restaurant?
It's funny you mentioned it. I was about to say just recently I've been pretty fond of bao in general. There's a nice place in town that we've been getting it. It's been pretty great. So big fan of that for sure.
Oh, awesome. By the way, while we were discussing our actually non-technical lives, there are a couple of things that came up as well. There was a question around the whole, what are the blogs that you refer to for latest security updates and Kubernetes? I think Steven mentioned Cloud Checklist. I'll definitely recommend that as well from Marco. Any other, I guess I've got the blog that you wrote, Christophe, but is there a central point that you guys direct people for latest security updates on Kubernetes? I don't know what that would be apart from, say, TLDRSec, Cloud Checklist. Is there any other that comes to mind?
Those are both excellent. If I can self-plug, if you're looking for general cloud security, I'd encourage you to take a look at Hacking the Cloud. Hackingthe.cloud is the domain. The intention is to be an open source encyclopedia of cloud offensive security techniques. We have a lot of AWS content because I happen to do a lot of AWS stuff. But if you're ever interested in, say, hey, how can somebody escalate privileges in IAM, or what potential attack surface is there for something like Lambda, Hacking the Cloud might be a good avenue. We're definitely missing quite a lot of material, but we're adding more over time and trying to get there until we finally cover everything, which I don't think we'll get there, but maybe someday.
No, but I'll definitely refer that in the show notes as well. But that's what we had time for. Thank you both for joining in. If you have any questions, feel free to reach out to Christophe and Nick on social media. Considering everything that you guys do on social media, you might as well share your social media link as well. Nick, did you want to share first?
Yep. So you can find me on Twitter, and I still call it Twitter, at Frechette_N. And then you can also find me on Mastodon. I'm on the Fostodon server, and my handle is @FrechetteN, all one word.
Oh, awesome. I'll add that in. What about you, Christophe?
Yeah, so Idiomatic, it's Christophe TD, like my name, .fr, because I'm French, and the same on Twitter and on infosec.exchange. I'm even on Blue Sky, so Christophe TD, I'm there. Feel free to PM me, I'm happy to talk about anything.
So I know what the FR is for. That makes sense. Okay, that actually makes sense. I appreciate you both coming on the show and sharing all this. And I will be back with another episode later next week. But thanks everyone for joining in. I will see you all in the next episode, and I'll see both Nick and Christophe soon as well. Thanks everyone.